Hey everyone. If you ever read the New York Times or the Wall Street Journal, which I'm sure that many of you do, every once in a while you may see headlines that say things like, greenhouse gas emissions in the US have gone up by 3% in the past year. Or you might see a headline that says something along the lines of, China's greenhouse gas emissions have now surpassed the emissions in the United States. And today I want to talk a little bit more about how do we know that sort of information and where do those numbers come from? And more importantly, what things do we not know about greenhouse gas emissions? So in the course of my PhD, I've been working on two particular greenhouse gases, methane and nitrous oxide. So whenever we talk about climate change, a lot of times we talk about CO2, carbon dioxide. But methane is the second most important long-lived greenhouse gas after CO2. And nitrous oxide is the third most important long-lived greenhouse gas after CO2 and methane. So first of all, before we dive in, I want to give everyone a little bit of a roadmap about what we're going to discuss today. First of all, I want to provide a little bit of context on these gases and the emissions of these gases, because I know that not everybody in this room spends all of their days studying the atmosphere like I do. Secondly, I want to talk about our approach. How do we go about estimating the emissions of these different gases? And then lastly, I want to talk about the results of the work that I've been doing in my PhD about emissions of greenhouse gases, and then finally provide a little bit of policy context. Because in the past few months, there have been a number of policy developments from the White House that could have an impact on everybody sitting in this room, and that's highly relevant to the work that I've been working on in my PhD. So first of all, I want to give everyone a little bit of context about emissions of the greenhouse gases that I study, particularly nitrous oxide and methane. So these two pie charts here are from the US Environmental Protection Agency. The pie chart on the left shows sources of nitrous oxide from anthropogenic emitters in the United States. And the pie chart on the right shows the EPA's estimate of anthropogenic emissions of methane in the United States. So gases like CO2 are emitted from cars and factories and all sorts of different sources. But methane and nitrous oxide in many ways are a little bit different. You can see nitrous oxide, there's one piece of that pie that dominates the entire pie chart. And for those of you who can't see, the biggest piece for N2O is agricultural soil management. So a lot of N2O emissions come from agricultural soils. Fertilizer has a lot of nitrogen in it. Farmers apply fertilizer and manure to soils, and some of that nitrogen will volatilize back into the atmosphere. And a fraction of that nitrogen that goes back into the atmosphere will go back into the atmosphere as N2O, a potent greenhouse gas. Methane, on the other hand, has some more diverse sources. There's a lot of methane, actually, that comes from cows and sheep, as we sort of heard about with the example of a sheep in a box in a previous talk. There are also a lot of methane that comes from natural gas and petroleum systems, also from coal mining and landfills. So you might be wondering, how does the Environmental Protection Agency get these beautiful bar charts and pie charts that you see here? Well, the Environmental Protection Agency uses basically an accounting method. They'll count out the total number of cows and sheep in the United States and estimate how much each cow is burping or farting, and then multiply those two numbers together and add it up over the entire US. And that's how you get these sort of numbers that we see here. It's an accounting type approach. The approach that I'm going to take, which I'll talk about in a minute, is very, very different. And you'll see that we get very different answers too. So here's a couple cartoons just for comic relief. For those of you who can't see, the one in the upper left says, "Have some more beans, Bessie," and the caption is "The global warming axis of evil." And on the lower right, the two cows, it just says, "Well, we're just trading emissions." Personally, I'm from the state of North Dakota. And when I was growing up as a kid, I used to help my aunt and uncle on their cattle ranch near Mandan. And I would help my uncle label cows using a branding iron. And now as a PhD student, I spend my time labeling greenhouse gas emissions from cows. So a little bit different, but somehow feels kind of full circle in a way. So I want to talk a little bit before we dive into some results about how we estimate emissions of these different greenhouse gases. In particular, using, in my case, I use actual measurements of these gases in the atmosphere. And I also use HPC resources. And I've put a schematic up here to kind of give everyone a little bit of a sense of how we go about doing this. The green star that you can see on the left-hand panel is a tall telecommunications tower. This particular tower here is for a TV station in Wisconsin. It's about the height of the Empire State Building. And at the very top of this tower, we put an instrument that measures concentrations of methane, CO2, and nitrous oxide in the atmosphere. And let's say, for example, that we have 2 hypothetical weeks. During week number 1, the air masses that are reaching this tower are coming from Lake Superior and Ontario. And on the right-hand side, you can see a hypothetical time series of the methane that we measure at this tower site. During week number 1, we see relatively little methane at this tower site. So we can sort of infer that there probably aren't that many methane sources over Lake Superior or southern Ontario. In contrast, in this hypothetical scenario, during week number 2, the air masses are coming from South Dakota, from Iowa, from Minnesota. I know that there are several people in this room from Iowa, and if you've been through Iowa and Minnesota, you know that there are a lot of cows in that part of the world, cows that like to burp a lot. And during week 2, lo and behold, we would measure higher greenhouse gas and methane measurements. And so we can put this relationship together to infer not only where we think the emissions are happening, but also how big those emissions are. And in our case, we have a few more tools that will help us. First of all, we don't just have this one tower, but we have a number of towers across the United States that measure greenhouse gases. Secondly, we use the NASA supercomputers in order to run a really high-resolution weather model. So we also know not just that the air is coming from Lake Superior or from Minnesota, but we know exactly where in Minnesota and how close those air masses are to reaching the ground. And then finally, we use a statistical method to sort of triangulate or interpolate and figure out where these emissions are and how big they are. So this method that we're using is based on atmospheric measurements and is very different from the sort of accounting measures that the Environmental Protection Agency uses. So here's a map of methane emissions, of methane measurements across the United States. The blue dots are towers, those tall telecommunications towers, and the yellow dots are measurements that we've taken from aircraft. This is for the year 2007 and 2008, which is the time period of the work that I've been doing. And several of these sites, to point out, are operated and run by scientists at Lawrence Berkeley National Lab. The network for N2O looks fairly similar, but it's a little bit smaller for nitrous oxide. So now let's dive into some results. I'm going to briefly touch on nitrous oxide and then spend some more time on methane. So this bar plot here shows our estimate of nitrous oxide emissions across both the United States and Canada. The bar on the left shows the budget estimated by an inventory called the EDGAR inventory, which is the most commonly used global inventory of greenhouse gases. The bar plot in the middle shows the estimate from the US Environmental Protection Agency. And the bar on the right in yellow shows our estimate using actual measurements in the atmosphere. And you can see that our estimate of N2O emissions in the United States is a bit bigger. In fact, not just a bit bigger, but about 2 to 3 times bigger than what EDGAR and the Environmental Protection Agency have estimated. So every once in a while in the news, you may see proposals that we should reduce our greenhouse gas emissions by 10% or 20%. But it turns out that our uncertainty in these emissions is a lot more than 10% or 20%, but more like 200% or 300%. So next, I want to talk a little bit more about methane. This top panel shows some of the key results from a study that I did on methane. The left panel shows our estimate of methane emissions in the US using atmospheric measurements. The middle panel shows the estimate from the EDGAR inventory, and the right panel shows the difference between our study and the EDGAR inventory. So in the right-hand panel, basically anything that is in blue or green means that we found emissions that are higher than the inventory. Anything that's in red or pink says that we found emissions that are lower than the inventory. And you can see that there's a lot more green and blue in this map than there is red and pink. And that sort of highlights one of the key results. First of all, we found that national emissions of methane are about 50% higher than estimated by the US Environmental Protection Agency. In particular, we found that 25% of all methane emissions in the US come from just 3 states, from Texas, Oklahoma, and Kansas. We're going to talk in a minute about why we think that is and why those states are a problem. And then lastly, we found that emissions from cattle and manure are about 2 times higher than the Environmental Protection Agency's estimate. So here's a map of gas production in the United States. And each dot indicates a gas well that is sized based upon how much gas is removed from that well. And you can see that this map looks strikingly similar to the methane emissions that we estimated. We found really big emissions in Texas, Oklahoma, and Kansas, and lo and behold, there are a lot of gas drills, or gas wells in Texas, Oklahoma, and Kansas. So we think this isn't a coincidence. These measurement sites that I talk about, not only do they measure methane, but they also measure a gas called propane. Propane is a gas that is not produced by cows, it's not produced by wetlands, it's only produced by 2 different things. Number 1, by people who use backyard propane grills, and then number 2, by the oil and gas industries. And these 2 plots here show a correlation between propane measurements in the atmosphere and methane measurements in the atmosphere on the x-axis at 2 sites, at a site in Oklahoma, one that's run by Lawrence Berkeley Lab, and by a site in Texas. And the correlation between propane and methane is higher at these sites in Oklahoma and Texas than anywhere else in the United States. So that means one of 2 possible things. Either number 1, people in Texas, Oklahoma just love to backyard grill, and they backyard grill 24 hours a day, 365 days a year. It's probably not very likely. Or it means that there have to be a lot of methane leaks coming from the oil and natural gas industry. So subsequent to our study, where we found these really high emissions from cows and from the oil and gas industry, there have been a couple interesting follow-ups. Our colleagues at NOAA, the National Oceanic and Atmospheric Administration, have done some measurements on road and from aircraft, and they found that the leak rate of methane from natural gas is somewhere between 2.6 and 17.3%. That compares to the Environmental Protection Agency's estimate of 0.88%. Interestingly, another study by Alvarez et al. 2012 found that if the leak rate from natural gas facilities is more than 3.2%, that means that natural gas would have a greater greenhouse gas impact than coal as an electricity source. So it's very probable that natural gas could have a higher greenhouse gas impact than coal. The Environmental Protection Agency, on the other hand, has also been making updates to their inventory. In fact, in 2013, when they released their new methane emissions estimate, they decreased the methane emissions estimate from natural gas by 25 to 30%. So the atmospheric observations are indicating one thing very clearly: the Environmental Protection Agency has been doing something completely different. And then lastly, I want to talk about some recent policy actions that I think are highly relevant not only to the work that I've done, but our future trajectory in terms of methane, and particularly methane from the natural gas industry. So in March of 2014, the White House announced its Climate Action Plan for regulating greenhouse gas emissions. And as part of that Climate Action Plan, they announced a methane strategy. So one component of their Climate Action Plan is that we should be investing more in natural gas as a power source. But as we've seen both from my study and follow-up studies from NOAA, if we were to switch, say, from coal to natural gas, our greenhouse gas emissions in the United States could actually go up, not necessarily go down, as the White House wants to do. Secondly, the White House has also instructed the Environmental Protection Agency to develop regulations for the natural gas sector by 2016. And furthermore, the White House has instructed the agency to develop additional rules for both methane emissions from coal mining and from landfills. So in a sense, if the White House's methane emission strategy is going to be successful, number one, we really want to know how much methane is coming from natural gas. Where is it coming from in the natural gas drilling process, which is something that we don't really know a whole lot about at the moment, except to know that it could be very high. And so a few conclusions from our study and the work that I've done in my PhD. First of all, we found that methane and nitrous oxide emissions are higher than existing inventory estimates. Secondly, we found large methane emissions both from ruminants, cows and sheep, and from the natural gas and oil sectors. So we clearly have our work cut out for us if we want to guarantee the success of the White House's methane emission strategy under its climate action plan. And our results show that there could be some worrying emissions from the natural gas industry that we have not accounted for. So with that, I'd like to thank everyone for listening, and thank in particular the CSGF Fellowship and a number of collaborators, including several at Lawrence Berkeley Lab and at Harvard and Stanford. Thank you.